Hello, everybody. Good afternoon. I hope you had a good day so far. I'm Sina Yazdanmehr, and I'm going to talk about fingerprint authentication in mobile banking apps. I'm a penetration tester and information security consultant with about 7 years of experience. My main area of interest and work is web and mobile application security. Currently, I'm working in Infigo information security as a penetration tester and consultant. Okay, in this presentation, first, I will talk about the root cause of this problem. Then I will elaborate on the traditional approach, which is PIN code authentication, and talk about its security challenges. After that, I will review how currently the developers are using the fingerprint authentication beside the traditional way with PIN code. Finally, we will see what are problems of the wrong implementation of fingerprint. And finally, I would talk about a better solution for this. Before I start our main topic, I need to explain how we measure security of a mobile application. Basically, the base assumption is that an attacker has full access to a device. I mean, physical access, the device is rooted, there is no screen lock, attacker is able to plug the device into his own computer, and under that circumstances, a secure application must be able to protect its data confidential and secure. So, we assume that all security mechanisms of operation system are already disabled, and application is responsible for its security. And please keep in mind that I'm talking just about a storage part in the client side, but the network part is as well important to be safe. It should be done over secure channels like TLS or SSL, and some security mechanisms like certificate pinning or proxy detection should be implemented in order to protect data over the network against network-based attacks like man in the middle or stuff like that. Okay, let's first see what's the problem. Almost all mobile applications use OTP in order to authenticate the user, tag along with other information that is used as a username. For example, it might be a token ID, it might be account number or IBAN number, and stuff like that. But in order to generate OTP, the mobile application, needs to use a secret key, which is common and shared between the server apps and the client app, in order to generate one-time password. This secret key is the most important thing in a mobile application, mobile banking application, of course, because if someone, a third party, can access the secret key, we'll be able to generate a valid OTP and authenticate to the system illegally. So, this secret key should be encrypted safe and securely and get stored on the device for future uses. And it should be just decrypted by an authorized user, which is the client of the application. It's all right so far, but the same secret key should be used for any type of authentication. It can be fingerprint authentication, face recognition authentication, any other type of biometric authentication, or the traditional one, PIN code authentication. Why? Because the OTP is based on this secret key. And if you use different secret key, that means the server-side app cannot validate the generated OTP. So for any type of authentication, the secret key must be the same in your application. Definitely all banks already have their own mobile banking app and just want to upgrade it with new type of authentication. So we need a way in order to upgrade your application with the less change in the database, in the code, and an easy-to-use approach for upgrading. In the current situation, when a user wants to start using a mobile banking application after installation and getting the activation information from the bank, first the user enters the data and the application manages to send it to the server-side applications. After validation, the mobile app will receive a secret key, maybe with other information about the account. Then, mobile application asks the user to enter a PIN in order to use that as an encryption key. And then, the mobile app will store encrypted secret key on the device. Now the application is ready in order to use in the future. So, in two other situations, the secret key will be used by the app. First, when the user wants to log into the system, and the second time, when a user wishes to sign a transaction. In that case, the user needs to first insert a PIN code, the right PIN code. The application manages to fetch the secret key, encrypted secret key from the device, decrypts that with the user PIN code. In case of successful decryption, use the plain text of secret key as a seed for the OTP algorithm, generates new OTP, and use for the current task. It might be login, or it might be signing a transaction, or other confidential tasks. Okay, it seems everything is encrypted, everything is all right, but this part even has some security challenges. And in case of wrong implementation or wrong type of secret key, it might make an attacker enabled to brute force the PIN code locally. Let me explain this here. Usually a brute force detection is implemented in the server-side application. And for example, after a certain number of wrong attempts, the server-side application blocks the user and forbidden for another trying. But in the local part, we won't be able to implement any brute force detection mechanism because an attacker will access to the ciphertext, and unfortunately there is no way. The only thing we can do is to use a good algorithm, a strong algorithm, and a really random and secure secret key. Let's take a look at its challenges. The secret key should be fully random and unpredictable. There shouldn't be any fixed pattern in order to generating new secret key for each user. It should be totally random, should be long enough, and it should be unique. The same secret key shouldn't be used for two users. Each user needs to have a unique and enough long secret key. Keep in mind, it should be random bytes, not characters, not alphabets, not numbers. It should be bytes, exactly random bytes, and unpredictable. Make sure you use a secure algorithm for encryption, and just stores the secret key. Don't append anything else to the secret key as a plain text. For example, I encountered a couple of cases that mobile applications, before encrypt the secret key, append some predictable, for example, epoch time, or some fixed data like a device ID to the secret key. That's a clue for the attacker in order to perform a local brute force attack against the ciphertext and try to find the right PIN code. And make sure your secret key size is the exact multiple of your cipher block size. Then you don't need to use padding schemes. Why? Padding, again, is a clue for the attacker in order to recognize in a brute force attack if the tried PIN code is the right PIN code or is the wrong PIN code. In a case that a couple of weeks ago I encountered, the application used the sequence of characters, not bytes. And the problem was, when you use a decryptor algorithm, in any case, with any encryption key, finally the decryptor returns you an output. It might be garbage bytes, or it might be the right plain text. The only way to recognize that, in this case, for wrong encryption key, which was the PIN code, application turns, the decryptor algorithm turns back some garbage bytes. But in case of successful decryption, the algorithm would turn back the sequence of characters. And in practice, it's almost impossible to receive full sequence of characters in case of using wrong PIN codes. So, keep in mind those parameters and try to implement your secret key generating process with these parameters. Okay, let's take a look at the current way of using fingerprint authentication by the developer. The three first steps are the same as past. User inputs the activation information, gets back some secret key information from the server side, and here tries to encrypt the data, the secret key, with a PIN code which the user determined. After that, ask the user, of course, it depends on the hardware availability, and first checks if the device supports fingerprint or not. In case of supporting the fingerprint, the application asks the user if you want to enable the fingerprint authentication feature or not. In case the user wishes to use fingerprint, the application generates a random key in order to use as an encryption key. Then manage to encrypt the user's PIN code and stores the encrypted PIN code on the device and stores that random key into the key store, which will be available to the application in case user authenticates himself by the fingerprint. After that, when user wants to log in or sign to the sign a transaction, first, application asks the user which way of authentication you would like to use. If the user wants to use the PIN code, everything will be the same as the past. Application receives the PIN code, decrypts the ciphertext of secret key, and manages to use plain text of secret key in order to generate OTP and other stuffs. But if the user wishes to use the fingerprint authentication, first application uses the fingerprint API in order to authenticate the user by his fingerprint. In case of successful authentication, the operation system gives permission to that application to use the key store. Now, the application can retrieve the encryption key from the key store and use that to decrypt the encrypted PIN code on the device. Now, in this situation, the application has the user's PIN code in its memory. So, now can use the PIN code in order to decrypt the secret key and again use the secret key for generating the OTP and proceed with the rest of the process. Okay, those are two remaining steps. Everything is encrypted, everything is confidential, and needs permission by the user fingerprint on the PIN code. So, why I'm talking here for you? Definitely there are some security issues here. First of all, the software-backed key stores are fully accessible to the root user. That means the way this key store works, if an application uses the key store and it stores some data in that, that data is isolated and is accessible just for the creator application. But the root user has the full access to the key store. That means in a rooted device, the root user can read all data in the key store. And definitely there are millions of old devices being in use. So A secure application must be able to be safe even on the old device. Of course, the hardware-backed key stores are more secure, and they aren't fully accessible even to the root user. I'm not sure about hardware attacks against the hardware-backed key store, but according to what Google says, it's fully secure. I'm not really sure, to be honest. When it comes to the mobile banking, that means it's dealing with your money. So it has a really high priority for you, and it should be really, really confidential and safe. Of course, definitely you know lots of people who use the same PIN code for everywhere, exactly everywhere. For credit card, for debit card, for mobile application, for online application, and even he has different bank accounts, maybe use the same PIN code for everywhere, any applications and any card. So, in case of an insecure application, by using this type of fingerprint implementation, and if an attacker can access to the key store and decrypts the PIN code, that means the attacker has a PIN code which is valid everywhere for that target. Maybe that PIN code is used even for the target's credit card or debit card or any other online applications. Of course, if you can combine the fingerprint authentication and the PIN code authentication, you can make it two-factor authentication in your application. It means this way has more capabilities that you can use easily. Okay. We should find a really easy to be implemented way, because other approach needs lots of change in the database, in the server-side application, maybe in your network structure. So, sometimes in this case, developer avoid to upgrade the application or maybe use insecure way. But there is definitely a better solution for that, and definitely it's easy to be implemented and it's secure and safe. What's that? You can easily split the secret key into different inequivalent parts and use each part for each type of authentication. How? Let's have a quick overview first to the OAuth algorithm, which are used for generating the OTP. There are three famous algorithms: HMAC-based or time-based, which usually is used for login and based on some factors, or challenge response, which usually is used for MAC authentication and generating a response in order to sign a transaction. All these algorithms need three main parameters. First is secret key, which we are talking about. The second is moving factor, and the moving factor causes the OTP to be unique each time, in each generating. It might be the time, current epoch time, or a counter. Counter is a random number which is getting increased each time after generating an OTP. And finally, a coefficient, because those algorithms' output will be a number will be a float number between 0 and 1. So we can use a coefficient to generate a bigger number. For example, if you use 10,000 as a coefficient, your OTP will be 4 digits. 100,000 gives you 5 digits of OTP, and so on. Okay, how can we play with these parameters in order to implement a secure authentication and multi-level authentication? Imagine your secret key is 30 bytes. This is just an asymptotation. It can be any length. When the mobile application receives the secret key, it can split the secret key into different sizes. In this case, I split the secret key in 20 bytes and 10 bytes, and use the first 20 bytes in order to PIN code authentication, the 10 bytes for the fingerprint authentication, and if the user wishes to do a two-factor authentication, I will concatenate again two parts of secret key and use the whole bytes in order to generate an OTP for two-factor authentication. And if user wants to use PIN code, the length of final OTP, in my case, it's really optional, you can use any length, will be 7 digits, 20 bytes of secret key will be used, and the user will have permission to sign to the application and sign the transaction. If the user wants to just use the fingerprint, the OTP length will be 6 digits, 10 bytes of secret key will be used, and user can just log into the system. That means by fingerprint authentication, the user will be able to just, for example, check the account balance, checks the reports and stuff like that, and cannot make any transaction or sign transactions. And if the user uses two-factor authentication, the whole secret key will be used, the OTP length will be 8 digits, and the user will have full authority to do everything with the mobile banking application is able to do. Let's dig into it and see how we can use this way. Let's again review the steps of using a mobile app. First was activation. 2 steps are at the beginning the same as the past. When the application receives the secret key, first split that into 2 parts. The bigger part will be used for PIN code authentication, and the application asks the user to enter a PIN. Then application encrypts the bigger part with the user PIN code, stores that on the device. Then the application generates a random encryption key, encrypt the smaller part of secret key by that random encryption key, stores the encrypted part on the device, and it stores the encryption key in the key store. Okay? Now, login process. By fingerprint authentication, if user wishes to use, application authenticates the user by his fingerprint. In case of successful authentication, the application, the mobile app, is able to fetch the encryption key from the key store, decrypts the smaller parts of the secret key, generates OTP, and log in the user to the system. All other steps will be the same as past. If user wants to enter the PIN code, application asks the user to input his PIN code, manage to decrypt the larger part of secret key from the storage, and use the larger part of secret key in order to generate OTP with the suitable lengths for PIN code authentication, and proceed with the rest of process. But what about two-factor authentication? First, application asks the user to enter the PIN, manage to decrypt the bigger part of the secret key. After that, asks user to authenticate himself with his fingerprints. Now application can retrieve the encryption key from the key store, manage to decrypt the smaller part of secret key. Now application has 2 parts of secret key in a plain text mode. So application can again join 2 parts and has the whole secret key and use that as the seed for the OTP algorithm, generate OTP with the suitable lengths, and send the data to the server-side app. Everything is done in the client side. Now, let's take a look at server-side application. In the server, definitely you have database and storage for storing the user data, and you have a process in order to generating a secret key for each user. As I told you at the beginning, you have nothing to do here because you're just generating OTP, generating the secret key the same as the past, it stores that on the database, and almost all process, changing process, is in the client side. But for OTP verification, when the server app receives data for authenticating or signing transactions, based on the length of received OTP, it decides which part or maybe the whole secret key should be used. Based on the length of secret key, it fetches the secret key. Based on the length of OTP, it fetches the whole secret key from the database, might use whole secret key for two-factor authentication or one part for any type of authentication, reproduces the OTP and validates the authenticator, the auth of user. All steps will be the same as current authentication based on the validity of OTP. But there are a couple of old phones which don't support the fingerprint sensor yet. And the good application must support even old devices. So just imagine there is no fingerprint sensor in the world, and you can just use the PIN code. Proceed everything like two-factor authentication mode. When you receive the secret key, just encrypt whole the secret key as the with the PIN code and store that on the device. The same as way you do it before fingerprint sensor comes to the mobile phone. Nothing has changed. So again, you don't need to change anything in the server-side app database or in your mobile app too much. But after all these talks, we should see if this way can sort out everything, all security challenges. Again, on a software-backed key store, if an attacker gets access to the device, finally he can manage to retrieve a smaller part of secret key. In that case, first of all, your PIN code won't be revealed to the attacker. That means your PIN code will remain secret. And if attacker can generate OTP with a smaller part of secret key and logins to your bank account, of course, some of your confidential information might be revealed, like your account balance, your transaction reports, but at least the attacker won't be able to make any transaction. He cannot sign transactions, can't just see your information. As I told you at the beginning, there are a couple of better ways in order to implement fingerprint authentication beside the PIN code authentication securely and safe, but those ways need lots of change in the code and the database. This way is the easiest way to be implemented and, of course, secure. Okay, any question maybe? Nothing?
Is this on? It is. Okay, so you mentioned earlier that our primary risk was due to the fact that we have to trust the operating system and its subroutines in order to check scan the fingerprint and retrieve it from the key store. If our app could have a low-level access to the scanning device, so we could bypass the whole operating system, in that case, the risk would be greatly reduced. Am I correct? And second, if we could use some kind of, let's say, TPM device on the mobile phone, could that reduce further the risk of compromise if case the device is rooted?
Yes, you are right, but I'm talking about general situation, general devices and normal situation, and all type of hardwares, because you know, device to device, based on the different hardwares and version of operation system, there might be different vulnerabilities, there might be different security issues, and generally, an application should take care of its security. I told you that without relying to the operation system or other mechanism. So it should be something general, not based on the different third party of mechanisms. Any other question? Okay. Thank you very much for your attention. Thanks.